This is stage 2 of the wheel demonstration. The overall purpose of the complete demonstration is using our tribrid modelling, working with surfaces, solids and triangles, to reverse engineer an alloy wheel, then re-engineer the design features. During this stage, we shall be using CAD-based reverse engineering techniques to generate a model of our wheel from the existing scan data. We will be showing sectioning, the creation and editing of 2D wireframe, surface and solid creation and editing, and also error analysis. In order to create a surface representative of the front face of the alloy wheel, we need to take a section through the model. We can use our dynamic sectioning function to do this. We can rotate this section around the model. We can turn on translucency to show the other half of the model. Then, at an appropriate point, select this button to capture a piece of wireframe representative of that section of the model. If we blank the triangle model from view now and rotate this around, we can see the piece of wireframe that has been captured. We can delete this piece as it won't be needed. If we turn on level 11, we can see we also have a piece of wireframe representative of the maximum values of our front face. So this in effect will be a design constraint. The front face of the alloy wheel cannot exceed the level of this piece of wireframe. If you view in Z for the moment, we can use our annotation functions to tell us the angle between these two pieces of wireframe. We can then use our rotate option to rotate the two pieces of wireframe onto the same planar level. We can delete this annotation as it won't be needed and view the wireframe in Y. First of all, using our design constraint wireframe, we can limit back our piece of cross-section wireframe. And if we select the wireframe that is a cross-section of our scan data, turn on curvature shading, we can see that the curvature of this line is not uniform at all. You will also see, if we take some measurements, that the radiuses involved in the creation of this curve are not round figures. So what we can do is reverse engineer this 2D piece of wireframe. We can do this using a selection of line and curve creation techniques. We can create several straight lines. Using our curve creation techniques, we can snap to key points on the existing curve. And instead of using the current values, we can enter more round figures. We can also use our annotation toolbar to highlight specific radii. And again, using our intelligent cursor, snap to key points in the curve as we create them and modify the values. We can delete the original curve now. As you can see, it has input specific points for us to snap to in our curve creation and assist us in building the rest of the curve. We could continue to build the curve like this, or if we delete the curve, we can use the existing one on level 13 that was created in the exact same way. Once a curve creation is completed, if we turn on curvature shading again, we can see that we have nice uniform curvature to this line. We can turn off level 11 now and redisplay the triangle model. We can use the freshly created piece of 2D wireframe to create a surface of revolution. If we reverse the surface, select both the surface and the triangle model, we can use our comparison analysis function to view the deviation in the model. If we turn on transparent shading to assist our viewing, we can see the areas in red where there are design features in the triangle model. So obviously the freshly created surface is not close to these. But the main areas where we expect the two to be close, we can see we have a nice green colour, and on our measurement chart that indicates that they are within tolerance. So if we turn off this now and turn on level 12, which is a solid representing our alloy wheel blank, we can then select the surface and using our Boolean functions create an intersection between the surface and the solid. So it has modified the solid using our created surface. We can turn this off for the moment, turn back on our triangle data. What we're going to do is create these holes or design features. In order to do this, we need to first gather data from the triangle model and then apply this to our solid design. We can open up our curve creation techniques and create a curve snapped to wireframe mesh. If we zoom into this and click key points around the inside of our hole feature, we can see that the curve has been pulled onto or snapped onto the triangle model. We can also see, if we view in Y, that it is sitting below our work plane. So we can use our curve projection option to project it flat onto the Z plane. We can blank our triangle model from view. Now, one of the design constraints that we're aware of is we do not want these hole features of the alloy wheel to exceed a radius of 170 from the center. So we can create an arc which will make up our design constraint, snap it to a key point, and then dynamically drag it until it has a suitable radius. If we take a closer look at this curved area here representing our hole feature, we can perform the same operations as before and re-engineer this section of the hole, inputting more appropriate round values. Once we get to this stage, we can delete the original curve and finish it off to the edge of our constraining curve. You'll see it will trim back the constraining curve. We can then turn on rim blank solid. If we select the freshly created piece of wireframe, we can use this to create a solid extrusion, if we double click on the solid extrusion, we can edit its values. We can place a draft angle in the solid extrusion. View from the side now, view in wireframe, we can see that this goes through the blank. Turn on our shading again, select it, and we can use our Boolean features to remove this solid from the main wheel blank. If we look in our solid history tree, if we select the Boolean removal, we can select to create a pattern of this. And this will create a pattern of the holes around the solid wheel blank. In the original scan data we had 6 hole features, so we can follow that. And you can see that we've created a full alloy wheel representative of our scan data. So you can see we've used our triangle model created from scan data to reverse engineer the wheel into a finished model. Incorporated into this reverse engineering were our predefined designing constraints. We've demonstrated our sectioning functions, our editing of 2D wireframe, our surface and solid creation and editing techniques, and our error analysis functionality.